Hi there, this is Amin. I'm going to go through the new tutorial working with the Spark RDD. So as you may know that RDD is a data structure in a Spark, which is read-only and read data line by line. So it means that if you are sending your data as a structured data or unstructured or semi-structured, any type of data, it's going to get your data and read your data line by line. So it means that the processing on your data would be record by record. So to do so, we need to work around with Python, all right? Because the the programming language that we're going to cover on this tutorial is based on PySpark, and we want to see how to apply Python on in parallel processing using Spark. So there are a bunch of sources, guys. I really recommend you to go through these sources for more information. But before doing so, please follow me. I want to take you into Spark RDD and see how we can work around with RDD using Python and PySpark. And yeah, let's kick off. So for big data processing, guys, as as we have to work with CPU and memory because we need to run data in parallel. We need to partition data, and then we need to uh, take advantage of CPU and memory, and to be able to run the processing on partition data. So why not to go through a bunch of uh, let's call it configuration or troubleshooting that you can apply on your system where your Spark is running, and or might be you want to run and configure Spark from beginning. Before doing so, is much better to get well enough information about the system, about the workstation, about the laptop, or about the cluster that you want to run Spark engine. So on the system, on the machine that you want to run a Spark, you need to open Jupyter Notebook. In this case, we are going to work with this Google Colab. And on this Google Colab, uh, what do I have? I mean, these are my, you know, availabilities of memory and disk. I have 12 gig memory. That is basically uh, most of most of these uh, capacities. Let's say they are available, and disk it's going to be 100 gigabyte. All right. So of course, guys, your side, your Google Colab configuration can be different by my own. So let's see what Google Colab as the free uh, the version, because I'm going to use the free version. What sort of hardware gonna to provide, guys, is really important to drill it down. Firstly, let's say you want to work for a company, they provide you different workstations, and you as a person, as a data engineer, it would be really professional to sit behind the machine and go through a bunch of commands to get familiar with hardware. All right, that's gonna be really important. So let's do a start. Let's insert code before installing PySpark. So what I want to do, let's see disk information. Like we have checking this. It's going to check disk space in Linux, right? So dash h means in the human readable format, please. So you can see that as we expecting, I have 100 gigabyte hard disk, right? I could figure it out here, and few more information that you can collect. So for us, maybe the first line would be enough, unless you have some other files directories going on. So why not to drill it down by adding few more syntaxes. So even this cat, then go to proc, right? And then mem info means memory info. And if you run it, so of course it's going to give us a detailed information about the memory running on this cloud, this Google Colab. So memory total is about 12 gig, right? This is what exactly, guys, I do have it, right? 12 gig availability of memory. So, and a few more information about buffer, about cache. For very big and huge size data and processing, if they're taking time, these are really important, to get into, into detail and drill it down, right, to see what's going on. Guys, this /proc is the directory in Linux, which is the virtual file system, providing information about system processing, system information, memory information, and so on. It means that even, here you can, there are lots of things. You can see that you can get information about devices, about DC stat, about file system, and memory, and more. Why not to also consider CPU info, right? Also, you can get information about CPU info, about CPU. So, but the best way to get information about CPU would be the syntax that we can use, this one, lscpu. All right, lscpu means display information about CPU architecture and characteristic. So on this Colab, we are having this architecture: CPU, right? Our address size, all right, byte order. So, and for us, most important part is this one, thread per core. It means that the free version of Google Colab provide just 2 cores. All right, for us. And if you want to run your code in parallel, you can have 2 cores, right? And then if you get like 8 partitions, and then your partition is gonna to go over processing in a pair, right? 2 by 2, because core here is 2. All right. So, and a few more information that you can consider, but for us at the first instance, the number of cores would be really important. Or might be you want to get them separately, like this one. You can say ls CPU. All right, so please vertical line grep. So and then here what we want to say that, for instance, grep for me, please look up, let's say this one, model name. Look up this one, model name. So you can say grep, model, name. If you want to, guys, get them, separately, right, one by one. Or as I said, that the most important one would be, grep this one, thread, this one, threads per core, right, this one. All right, it's gonna say, all right, 2 thread per core. This is what we really needed. All right, guys, and a few more, right? You can get cache to find, the availability of cache and so on. All right, you can see that caches and availabilities of caches. All right, so you can find them out. So feel free to get familiar with the hardware, guys. These are really important. So after getting, well enough information about the machine, hardware and configuration, let's install PySpark. Guys, this is, on Google Colab, you need to run it while your session is active. So it means that at this session, you need to install it just for one time. All right, you don't need to run it again and again. But if you close the session, right, and open another one and go into the Colab, you need again install PySpark. All right, because it's active while your session is active. So it's going to download the latest release. At this time, I'm recording this video. So release 3.5. All right, it's going to be the latest release. All right, successfully installed, right? So let's now configure it. So from PySpark, we need two important packages: import Spark configuration and Spark context, right? So Spark configuration to configure, entire engine and the entire cluster, and Spark context, which is in charge of, like is the driver node, right? In charge of uh, Spark when it's gonna deal with end user. So let's create an instance of Spark configuration. So configuration, please take this Spark configuration, let's just take it as an instance. And then we can set configuration. Guys, we need to go through a bunch of configuration that these are really needed. So configuration set spark dot app dot name. All right. So let's name it, PySpark from 0, something like this. Configuration.set. I wish to say spark.master guide. This is really important attribute here. So since here we want to work with let's say that, just give me a second. All right. So a Spark master means that set the number of cores. All right. So here we have to say where are these cores? Local machine. At this machine we are working. Guys, machine, not the physical one you are sitting behind, that means Google Colab. All right. So then asterisk means please let us utilize as many as core available. All right. So it means that run Spark in the local mode. All right, this is what we can do in the local mode. But if you want to work on the cluster mode, you need to do something like this. You have to say that Spark master. All right. So you need to give different things, like you have to say that Spark colon, all right, // and then guys, the driver. Where is driver node? Okay, so port 7077, guys, port 7077 is the default port, all right, used for a Spark master service. Okay, that's the reason. You can also change it. All right, if you want to change it, you need to change it while installing. So guys, on this Google Colab, why we have no access to Spark installation to decide where to install and what port to select for installation, you can take, this default one. And then the rest, you need to add, more information, like you can add, let's say you have two more workstations, say worker node. All right, let's say worker one. So you have to add worker one IP address, and then again 7077. Maybe you have one more worker node, worker two, IP address, again 7077. So guys, how Spark or how Python compiler can distinguish which one is master node and which ones are worker node? Guys, just because of this Spark colon // it gets this one as master, as a driver node. All right, and then the rest will be worker node. Okay, so by the way, in this case, we want to keep working with, the local mode. So on the local mode configuration set spark dot driver. So go through driver, which is, the same machine that we are working, the memory. So guys, we have 12 gig availability, right? But now is 11 gig, right? 1 gig is gone. So let's say 11 gig. For 11 gig, about 11 gig, why not to take, 4 gig, for driver node? All right, set spark dot then executor, which is, your worker node. So guys, at this machine, both worker and driver, they are same because I'm running on the local machine here. So if I say 8 gig, it means that 12 gigs go for the same machine, right? A few for driver and few for uh, execution, right? Both on the same machine. So let's add few more configuration like core. All right, Spark dot driver. All right, dot core. It means on the driver how many cores you wish to take. Here we said that please take, as many as core available. All right. So, but guys, here we could find it out. There are only 2 threads, right, that you can apply. It means that if here you say, please take, 4 cores for me, if you run it, there you are not going to get any error, right? There is no error. The issue is, since this 4 is not available, it's going to change automatically to 2 cores. All right. So, but since we know there are only 2 cores, right? Why not to get it, 2 cores? Or maybe you can get this one as the input. All right. It means that you can get this one and then it's going to get it automatically on board. All right. So why not to also provide Spark, not the driver one, executor one. So executor, do the same thing. Maybe for driver, you can take 1 core. All right. Because we are working on single machine here, right? The local machine. And then, but for execution, it means for parallel processing, I would say, okay, run on 2 cores. All right. So then let's initialize Spark using using the configuration, something like this. How? SC, let's name it C, Spark context. This is the habit we usually use. SC means Spark context. All right, configuration is going to be configuration. And let's print SC, right, to make sure everything is as we expect. All right, great. So once you get this message, it means it's already done. So let me add a few more codes, okay? So if you want to make sure they are all, available as you configured, it's going to be really easy. Just say configuration. Instead of set, you need to say get. All right. Or maybe this one. I can copy this one. All right. Put it here. Change set to get. All right. And remove this 4G. All right. And if you run it, it says 4G, right? Means this is what you have done. So you can check all together, one by one if you wish. So, okay, guys, a Spark cluster on the local machine is ready for parallel processing. So first of all, we need to load data. So data, since I'm going to take, this tutorial from 0, let's take a small size data because I want to go through RDD coding and programming to see how we can apply. And whenever you get, the larger size of data, then you are able to work around, because at this stage the size is not a big deal. The deal here is how to write in parallel coding using PySpark. So let me import random package, and then I want to generate random numbers. So random.sample. All right. So let me go through the range of 0 to 100 and generate for me 30 numbers, please. If I say print data, let's see what's going on. All right, these are 30. Maybe I can close that resources. So 30 numbers. All right, so guys, this is random. Once you run it, your numbers would be different. All right, at this stage, we need to load data in Spark. So how to do so? RDD is this sc.parallelize. All right, this is the method. What to parallelize? Data. So let's consider 4 partitions, okay, for training purposes. I want to partition these data into 4 partitions, and let's, run it. So we are expecting to write RDD, right, and get output. So guys, but once you write RDD, there is nothing, right? This is not human readable output. So where is data? So how to work with data? In Spark, we need to follow two operators, transformation and action. So let me take you on this RDD programming. All right, this one, first one. So here you can see that transformation and actions. All right, these are two operators we need to use. So firstly, start with transformation. So guys, if you want to work with data and PySpark, we need to respect these methods. All right. So what does map do? Return a new distributed data set, means new RDD, by passing each element of the source through a function. It means you want to like do calculation. You want to calculate a profit. You want to multiply your data. You can use map. Filter, return a new data set form by selecting those elements. Flat map, map partition, guys. Each method here provides specific action, specific, calculation. All right. We will go through them. We need to know what they are. There are a handy number of, transformation. These are really easy, right? I want to take you guys into a few of them to get idea. Action. Action, it's going to take your data into the readable format. All right. Transformation, there is no readable format in the transformation. If you want to make your data readable, means to print it out, you need to use action method like reduce, like collect, return all elements, count number of elements. First, the first element, take, return an array with the first n element, and a few more, right? Not too many, basically, right? Not too many. So it means that here, I would say that, so if you have small size data like this one, you are allowed to use dot collect. Okay, this is an action. If I say dot collect, great, so can see that now I can see data. But guys, dot collect means that go over all partitions, means 4 partitions, and take them all together to print them out. So guys, make sure dot collect is very risky and dangerous for huge size data, because we cannot print out like 1 GB data. So please avoid collect. This is since for training purpose, and the data, is very small. I'm able to use collect. So the safe side is going to be, say, rdd.take. I want to take first 5 data. All right, it's going to go over first partition, collect first, collect 5 data. If there is less than 5, it's going to go to next partition and then, collect it. So, all right, that's okay, right? Let me add a few more code. So that's really okay, right? We are now able to, work with data, right? To collect data or take data, because I want to see data. But guys, I want to see data in the format of partition. So if you want to, let's say, print data per partition, again, guys, this is for training purpose. All right, for really big size data, we cannot take this syntax. If I say gloom means take each partition and collect partition by partition. If I run, so perfect, can see that it says these numbers, they are now in partition 1, guys, means these data, partition 1, from 19 to 6, partition 2, from 18 to 89, partition 3, and the rest in partition 4, because we ask Spark to please divide our data into 4 partition fairly. That's the reason we have exactly the same number of data in the first 3 partitions. But here, since we have 2 more, it's going to keep those 2 more at the last partition. All right. So let me take this one into the whiteboard, okay, and see what's going on. All right. So as we notice, we have 4 partitions. All right, let's say this is partition 1. All right, let's say partition 1, 2, 3. All right, and why not to get, one more? And, one more partition. All right. So what's going on? Also, we ask, Spark to please arrange 2 cores for us. This is core 1 and this is core 2. All right. Then while, running your Spark, it's going to, get this partition. Let's say this is partition 1. All right. This is partition 2, partition 3, partition 4. These 2 will be working with core 1 and these 2 will be working with core 2 because we have to, distribute data fairly across the core. So what's going on? This one is going to be, the first data, let's say here. All right, this is first partition. Okay, so this is second partition. All right, and this is third one. And this is last one. All right, great. Okay, we have now 4 partitions. So what we want to do here, we have data, we could print them out. I want to go through a calculation. The calculation means that, let's say I want to get each number like 15, 54, and the rest of the number. And then let's say I want to multiply it by the number. All right, so it means that I do expect to do this one. So after processing, so this partition and this partition, they will be run in parallel on core 1 and core 2 to do your processing. So my processing is to, to get like 15 plus 2, 17, 56, right, 34, and the rest. And same gonna be here, 20, 35, 40, and more. This is the first, first time running, and then you can run, these 2 cells in parallel and do the same thing. All right, and do the same thing means it's going to be 21, 47, and so on. And this one is going to be 22, 95, and so on. Okay, how to do it? If you want to do this one, you need to write a function in Python to do this one. Let's do it. So here, I want to say that. Let's say that. Let's also import random number. I think we did it. Okay, we did it on top. We don't need to do that. You need to write a Python function. Let's say my function. I want to get one input x. All right. I want to return something like this. Return this x. Let's say I want to say multiply. Add it by the random number by a random integer between 1 and 10. And then at the end, I want to divide it by 2. Okay, let's say this is what I want to do. So let's run it. So now how I'm able to apply this function, all right, on this scenario. So you need to come over here, go to the transformation and see which one of these methods can do that. So map, take a function. Filter, take a function. Flat map, take a function. Map partition, take a function. All right. Return a new distributed data set formed by passing each element of the sort through a function call func. Guys, this is what exactly we want, map, right? So we can come back here. And then here I want to say that RDD1, please take over RDD dot map. What to map is my function. Very easy, right? So now let's see what's going on at each partition. So guys, again, these gloom you can apply on small size data. Okay, since this is for training purpose, I'm using gloom, right, to show you what's going on the partitions. So if I run this, what's happening is going to get this function, all right, and run it in parallel, as I explained here. Parallel means that here we do run, these and these firstly, and then these and these secondly. Why? Because of, these cores, all right? Because core can accept one job at the same time to process your data. So you can see that now, first partition, second partition, third partition, and last partition. We could do it easily, all right? So in Python, if you are a Python coder and you know Python, if you're not familiar still with Python, please go through Python and learn as a self-study. So also this one, guys, you can, I want to copy and paste it here. This my function, let's take now RDD2, all right, RDD2. Or maybe RDD, just take it RDD1. This my function, guys. In Python, you can use anonymous functioning. Anonymous functioning means that I want to get this action. Okay, copy the action, and action means, guys, the main processing here, right? Collect it and copy it and save it here. Okay, and then here you have to say lambda. Lambda means this is anonymous function. It means I'm not going to define the function. I'm just going to take the main business, right? The main processing, and then you have to provide who is x here. Then you have to say lambda x colon. So x here means the input from map. All right, the input from map. All right, so lambda means anonymous functioning. X means each value coming from map means, firstly this one, secondly this one, and one by one. And then do this. All right, this one, guys, is exactly this one. All right, if you run it, you can see the output, guys. But since here we have random, that's the reason these numbers is different. All right, 9.5, 29.5, and so on. All right, this is what we can do. But let's say that I want to filter. Okay, let's say that filter data based on the division by number 3. It means that I want to divide each number, right? I want to divide each number to 3. The original one, this one, the RDD one, this one. Okay, I want to divide them one by one to number 3. If the remainder is 0, collect it. All right, means there is a condition. So how to write the condition, guys? Firstly, Python. So Python, please let me say def. Let's say division. Let's say by 3, something like this. Or maybe let's say remainder, something like this, by 3. So get input, and then I have to see that if x, all right, the division, the remainder of division by 3, if it's 0, okay, and then return x. Okay, guys, this is the Python. All right, so make sure to run it. Okay, let me add a few more code. Make sure to run it. Okay, now how to apply this one? How to apply this? You need to go back here. So filter, return a new dataset by selecting those element of the source on which function return true, means your condition should be met, right? So here I want to say RDD3, please go over RDD. That in this time I want to use filter. Why? Because guys, here I have a condition. I have a filter. So again, filter what? Based on this function. Okay, let's again take RDD tree glom to see the output. All right, to see the output. If I run this, all right, guys, can see that these are all the numbers that the division by 3 is 0. These are coming from first partition, means from this partition. The second partition, we expect to get 45, 57, and number 6, right? 3 numbers as we have here, right? And the rest. So how to do it? How to do it with anonymous functioning? For anonymous functioning, you need to, again, do this. I mean, remove this function name, type lambda, x, y, a, whatever, right? Let's say x. What is x here? The input from partitions. All right. What to do with this? You need to take this one into one single line. How to write it into the single line? You have to say x is division by 3. If it's 0, means return it. So if I run this, so guys, exactly the same output, right? This output is exactly same as this. Okay, so let's say that I want to go through RDD tree. Let's say I want to calculate all these numbers together. Okay, all these numbers together. How is that happen in Spark? Because in Spark we have to take partitions separately, right? Each partition separately, and then collect data accordingly. But the next task here is, let's say, calculate the summation of all numbers in RDD tree. Guys, this one we call aggregation. So guys, aggregation can be summation, can be subtraction, can be multiplication, and can be division. So you can name it like all together, you can call aggregation. Why? Because I want to collect all data together, divide them on each other, or multiply on each other, or do addition on each other. All right. So how does it work in Spark? Let me take you into, this one again. So to do so, we can do something like this. Here, let me, drop everything. All right. No, not this one. All right. So let's say after filtering, right? We had filtering. Filtering provide this, data for us. Filtering got, 15 from here, 40, 54 from here, 51 from here, 60 and 66 from here, right? And then, at this in parallel, we have to consider this one, 18, 33, all right, just 2, and from this one, 45, 57, right, and number 6. For this one, 93, and 12, right? Let's double check, 12, 93, 18, 33, 3 number and so on. Okay. In Spark, if you want to do aggregation, aggregation happens on this one. There is a method we call reduce. Aggregate, guys, this is the keyword. Aggregate the elements of the data set. That's it. The function should be cumulative or commutative. So the function, guys, should be a cumulative type of, aggregation. It means that those, operators I mentioned, plus, subtract, division, and so on. All right. So how to do so? Let's see how does it work. So first of all, once you do addition, all right, So addition means that you need to add, 2 by 2. It means that firstly, please do addition. 15 plus 54 is going to be 69, right? And then 69 plus, 51. What's going to be? It's going to be 120. All right. 120 plus 60 going to be 180. And 180 plus 66 is going to be 246. All right. So it means that this is 246. What about this? It's going to be 5108, right? This one's gonna be. So guys, if you want to take it in parallel, this one and this one, they do in parallel, run in parallel. It means that it's gonna be 51. All right. And these two together, then we go through this and this, right? So the top one is gonna be 100. It's gonna be 108, if I'm not wrong. All right, and the last one, 93 plus 12, is gonna be 105. All right, then we have to take these two together, means A plus B is going to be or not these two, sorry about that, not these two. We need to take them in parallel, right? It means that next time maybe this color, this one and this one, right? They get together, it's gonna be 792, and then these two gonna to get together 312, and then these two gonna to go together. All right, this is the way we're gonna do that. How to do so? It means that how to implement. You just need to send this A plus B. What is A? The left number. What is B? The right number. Means 15 left number, 54 right number. Do summation. 51 plus 69, 59, 51 is the left number and 69 is the right number. In this case, 246 is the left number, means this is A, and 51 is the right number, which is B. So how to do it? Follow me here. You need to say that RDD3 means this one. All right. Dot radius. All right. You need to send a function, guys. Anonymous function in lambda. So guys, here we need two numbers, A and B, or A or X and Y, whatever. Then do this one, A plus B. That's it. If I run, Spark knows how to take it over 510, right? It means this two is 510. Let's consider few more discussion, which is really important at this stage that you need to consider. These are, let's call union. All right, union. It means that here we have transformation. Where are you? So union and intersection. Return a new dataset that contains the union of elements, and here the intersection means find the matches. So these are also really important. Let's take it into consideration. Let me say data one is this random sample. Guys, I'm taking these again for training purpose to get the idea behind that. All right, data one 15 number, and here also 15 number, and let's name it data two. All right, so then what I'm going to do, let's create RDD6. For instance, maybe RDD4. Let's RDD6. Okay, sc.parallelize. Let's send them into Spark. Is data one. So for training purpose, let's get two partitions. All right, and let's me take next one, three partitions, RDD7 and data two. All right, so and then let's print them out. Okay, let's say print RDD6 dot again Bloom. Guys, we use it just for training purpose again on the small size data, and this is RDD7. All right, or maybe you can name, like RDD6 is this one, and RDD7 is this one. So let's run. Perfect. So RDD6 in 2 partitions, RDD7 in 3 partitions. So here I would say that RDD union, all right, is going to be this RDD6 dot union by RDD7. Okay, and this RDD union, please dot bloom for training purpose again dot collect. If you run, so union means collect them together. What we expect to get all together. How many partitions we have? 1, 2, 3, 4, 5. To get exactly 5 partitions. 1, 2, 3, 4, 5. Exactly keeping, the same partitions because this is union. All right. What about intersect? If I say RDD intersection, it's going to be RDD6 dot inter, press tab intersection RDD7. All right, and then RDD intersection dot loom dot collect. What's going on? So guys, once you do something like this, what we achieve here, so intersection guys, these two, first is going to consider 18. Do we have 18 in RDD7? Yes, we do. So it's going to collect 18. 12. Is there 12 in RDD7? Yes, there is this one. So it's going to also print it out. 13. Is there similarity? No, there isn't. So you have to ignore. Number 3, right? You have to take it number by number. But what did you notice, guys, here? Shuffling. 18 is in partition 4, 12 is in partition 3, but they are together, right? How many partition? 1, 2, 3, 4, 5. Why there are 5 partitions? Why not 3 partitions? Why not 2 partitions? So it's, guys, this 5 partition is not because of 2 and 3, right? It happened, by chance here. Let me change it. Let me run again, this random. You take less number, 10 number. All right, and then this one union 5, 1, 2, 3, 4, 5. All right, for the intersection, the idea is okay. Now it's much better. So can you see that? It's gonna to take, like, let's do again, gonna to get number 3, go through RDD7. Is there number 3? No, it's not. Ignore it. Number 9. Is there number 9 RDD7? Yes, there is. Because intersection means find match, right? 9 is here. But can you see that data shuffled? All right. Few partitions empty like this and this. Few partitions just one number like this and this. And few others more than one number. So guys, because intersection is very expensive operation, right? Because it's shuffle data between partitions. Okay, so but let's say this is small size data that we can see what's going on in each partition, right? So how to do on large size data? Guys, on the large size data, we need to do something like this. You need to come over here. There is something we call this one, map partition. So map is there, okay, but this mapping is gonna be happen over each partition separately. There is no aggregation at the end. All right, similar to map, but run separately on each partition. Okay, so what does it mean? This is what exactly I need. It means that RDD intersection. Let's consider this output is large size on the large size data. So dot map partitions, again lambda anonymous functioning. So you can take partition, you can take p whatever. So p means that each value, right? Each value, like here firstly 5, then empty, then 17, 12, and so on. So p here means p, this one, because it's map partition. P is number 5. Then p is this empty one. Then p is this 3. Guys, we said partition by partition, right? Not number by number. So p, let's call maybe partition to remind it this is the partition, not the number. So convert it to list, the values. All right, and then get the length. Because I want to get the because of getting the length, I'm using list. All right. Right. So that's it. Right, length, and maybe at the end you can collect. Okay, you can collect. If you have many partition, you can also avoid collect. If you have like less than 100 partitions, sometimes even 200 partitions, depends on your hardware, is it still okay? So if I run it, so guys, error, right? It's good to, okay, it says int object is not iterable. It means that you need to take everything into the list format. It means that here, take this length into the list format. Okay, then run. Guys, perfect. You can see that it says first partition there is one number, second partition there is no number, third partition there are three numbers. Guys, this is really perfect. This is very great trick you can apply on the partition to count how many data are available in each partition. Why we need that? Because you can modify the partition. You can modify partition. How? You can say that RDD new, for instance, RDD intersection. I know that you have very limited number of data. Please coalesce to two partitions. All right, this one coalesce. So if I search coalesce, so decrease the number of partitions. This is a part of transformation operators. All right, so two. All right, and then why not to double check if it's true? So let's say dot gloom dot collect. If I run, guys can see that exactly the same numbers, but it's taking into two partitions, but because of the size, right, it's going to coalesce into two partitions. If we run it, it's going to keep one partition because guys, it's very small data. Maybe you can coalesce to one partition. All right, because original one was into 5 partitions, and then you can decide to decrease the size of the partitions. So guys, these are basically enough, to know how to work around with RDD. So now I want to take you to a challenging task here and see how does it work. Let's say we have a document, all right, that this document is in the list format, okay, this is the document. So you need to parallelize to say, all right, please Spark context, take it over and do it into two partitions, okay, into two partitions, okay. What I want to do, I want to go through word count. It means I want to count how many Apache there are, how many Spark there are, how many E's there are, right? And few more. At the first instant, guys, I want to drop a few words here that length is 1 like A and is like 2, because these are not the main words or main letters that I'm going to take for counting. So I want to drop them. How to drop them? If you work with small size data, still Python, right? What type of Python? regex is still the solution. But here you have to write a function to do this regex. How? Then you need to apply this regex on each partition. So since here we have two partitions, you can also, get gloom, right, to see what's going on basically. So documents, all right, dot gloom, dot collect. If you do like this, so you can see that it's going to say that these 3 lines, the first partition, all right, these are the last partition, okay, partition 2. So, but what I want to do, I have to write the function, go through each partition line by line, because RDD read data line by line, and drop, the words with length of 2 and length of 1. So how to do so? Write function. So document dot. So guys, map. All right, map. Then a lambda means anonymous functioning. Get, let's say you can call it line, because I'm going to take line by line. So then I would say that RE regex. So where are you, regex? Import RE. Or maybe we can do it with the function. Let's say that def, let's say regex function. Okay. get, let's say, line, something like this. So what I want to do, I want to return what I want to return. I want to get each line, but guys, this is re regex dot. I want to use sub, means replace. What to replace? I need to write a regex to find the word of the length of is 1 and 2. So R, which is the regex. So please find W means any character, sorry, W any alphanumeric 1 or 2 length. Okay, make sure to add this B, means that these are it will match the specified pattern anywhere within a word rather than specifically at the word boundaries. What does it mean? Let me tell you. So then I would say that please replace this one with empty value, and then on the let's say on this line. Okay, so why not at the end? Let's run this one, guys. Let's firstly run this one. So here I would say that run this. Okay, so if I run it, oh sorry guys, make sure to say collect. Okay, collect. So guys, one lesson, you can add these transformation and action back to back. Firstly map is running, then collect is running. So what you notice, Apache Spark, so is and a, they are gone, right? Once they are gone, just 2 white spaces is left, right? 2 white spaces left. So unified analytics, and what is like here, Hadoop is is gone, right? We drop them. So if you remove this B, then it will be a disaster. Let me run it. So you can see that there is nothing. Why? Because \w means any alphanumeric, the length of 1 and 2. So start with A. A is exactly length 1. It's going to drop it. Then P, exactly length is 1. So can we see that, guys? There is a cutoff because it's going to cut off A from Apache, cut off P from Apache. So, but if you put B at the beginning, at the end, means please do not apply cutoff. Okay, get the entire word and then count the length. Get the entire word and then count the length. Right? Get the complete word and then do that. Okay, so perfect. But still, these are the problem, right? The white spaces. Why not at the end to say replace? All right, replace, these maybe 1, 2 white spaces with nothing, means drop them. Okay, means drop them. So can see that I'm running this Python using map over each partition. If you run, perfect, guys, they are gone right now. Apache Spark is A is gone, and then unified is there, right? And the rest. Great, we could do that, right? So why not to collect it into filtered document, or let's say filtered doc. All right, and run again. So what we want to do, the task is word count. Okay, now I have to count how many Apache there are, how many Spark there are, and so on. How we can do that? Let me show you. Let's say here we have 2 partitions, right? If you notice, we had 2 partitions. Partition 1, partition 2. All right. So what happened in partition 1? If you remember, we had like Apache. Okay, so maybe I can take it from the file. All right. So if you remember, these are in the first partition. All right. But you know that I need to really put it like this. These are in the first partition, right? And the rest, second partition, right? All right, the rest is here. These are here, and these are here. All right. So how to count, guys. If you want to count number of words, firstly you need to create a logic for your own, right, to how to do it. For me, I want to get each word separately, okay, like Apache. And then I want to add number 1 in front of it. Means there is one Apache. I want to take a Spark separately and add number 1 in front of it. Or maybe somewhere else, maybe here, right? Maybe it might be here. Another Spark is there. Okay, Spark 1. Okay, you can do all these together. There is a reason we are doing that. Let's say in the second partition, you have like Java. You can see that Java, I'm adding number 1 in front of it. Let's say this object, I'm adding object, in front of it. Maybe there is Apache here, right? Apache, I'm adding in front of it. Maybe there is a Spark, right? Spark in front of it. All right. So what's happening at the end, guys? This is mapping, right? Why we call it mapping? Because we went through each partition word by word. So how to do so? How to do this stuff? You need to do like this. So filter dot, right? Please dot. So guys, here we have to use flat map. Flat map is here. All right, similar to map, but each input item can be mapped to 0 or more output item. This is what we need that. All right, so here flat map, please lambda anonymous functioning, get each line and split it. Okay, split it, please, because I need word by word split. Split, guys. Why split? Because I need to take Apache, then take a Spark, then take Unified, and then take, I need to take them one by one. So then you need to add number 1 in front of each. How to add number 1 in front of each? I want to do another map. Okay, now we have to do map. Map lambda. Let me name it word. Get each word and do this one. Word number 1. Okay, it means this one, right? Apache number 1, Spark number 1, Spark number 1, and more Java number 1, object number 1, and more, right? This is what we did. Why we need to do so? Because guys, at the end, we need to aggregate these two partitions based on the keys. So first of all, Apache is the key, Apache. So number 1 means 1 occurrence, and there is one more, means there are totally 2 occurrences. Guys, did you see that? Why we need to do number 1 in front of each? For a Spark, we have number 1 means 1 occurrence, 2 occurrences, and 3 occurrences, right? There are 3 occurrences. So it's done. We need to go through this. Java, how many occurrences? Just 1, right? Just 1. And many more. How to do this, guys? This is exactly reduce. Okay, but here we have to use reduce by key. Why we have to use reduce by key, guys? Because this is exactly the format of key, right? And value, guys. This is dictionary, key and value, right? Apache is key, number 1 is value. Spark is key, number 1 is value. It means that I need to go over firstly all Apaches, means Apache here and Apache here, right? Means this is the key, and then count the number of these numbers in front of it. Then you have to go through the second key, which is a Spark here, all right, and then go over Spark and collect the values, means 1 plus 1 plus 1. Okay, how to do so? You need to use backslash. Guys, I'm using backslash to go to the next line. So here reduce, but by key. Okay, so then the logic is same, lambda a and b, and this reduce is always easy. You just need to add the aggregation, I plus b, and by key, this key is going to look after these keys, Apache firstly, Spark secondly, Java thirdly, and so on. All right, and that's it. At the end, you can say dot collect and run. Okay, there is a problem. So flat map, lambda line, line that is split. All right. So list object has no attribute flat map. Filter doc. Oh, sorry guys, this collect, I have to remove it. Okay, let's run it and let's run it. So my wrong, this is reduce spiky and then run. Perfect, guys. We could count them. There is only one Apache, there is only one Spark. So if we move forward, there are 5 programming, 5 languages. There are 2 general purpose, and the rest, like there are 8 occurrences of 4. There are 5 occurrences of and, 2 occurrences of software, and more. Okay, this is how we can count the number of words. So let's make it a bit challenging still. So let's say that calculate. All right, the frequency of each word. All right, in the collection. So how to do so? We need to go through this output, which is, this filter data, right? So why not to name it, this word, counts, all right? And let me remove this collect from here, okay? And keep this word count as the RDD, right? Word counts dot collect, okay? Let me copy this one. Let's run again. Okay, perfect, right? Is there? So I want to say that, let's say total count. So total count means that I have to count this one. 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 1. Guys, I want to count them. How? You can do something like this. So this word count means, this one. I need to get, this index, means this is a tuple. Relational is index 0, 1 is index 1. This is tuple, right? Held is index 1, number 1 is index, held is index 0, 1 is index 1. Managing is index 0, 1 is index 1. I have to get, this index 1. How? Again, map, right? Because I want to collect one by one. So lambda, please go over each value x, okay? And then get me just second item, means the numbers 1, 1, 1, 2, 1, 1, and more, right? 2, 5, 1, 1, and many more. And then how to aggregate them? Reduce, guys. I think now you are getting the idea behind that. Lambda, get A and B, and then A plus B. Guys, this reduce is always like this. Okay, so total count, let me print it out. Okay, 90, guys, totally 90 words we have, right? So why not to do word frequency? Okay, word frequency mean that take this word count, all right, then dot map. So what I want to do, I want to do something like this. I want to say that statistical number 1 divided by this 90, because I want to calculate the frequency. Computing number 1 divided by 90. All right, so software, then number 2 divided by 90, and number 5 divided by 90. How to do so, guys? Again, here we have to do one by one. That's the reason we have to use map. So lambda, please get each value for me, okay, and create still a tuple for me. So the first part of tuple is x0 still. So guys, this is, let's say this is x. Okay, I want to keep statistical as it is. Okay, keep it as it is, comma. So, but this number 1, I want to change it. So it was before x1. Now I want to divide it to total counts. That's it. This is word frequency. Okay, then if you print it out. Oh, sorry, I need to say collect. Guys, can see that these are the frequencies, right? Because there are number 1 divided by 90, number 1 divided by 90. All right, then you can get something like this. All right, so what I want to do, let's say, or maybe here you can say round. Okay, round this one with 2. Okay, and then just let me say word count dot collect. Okay, I think it's much better now, right? You can see the round. So why not to do, let's say, display the top n words with the highest frequency. Okay, let's take n, let's say top 3. All right. So how to get top 3, guys? We need to get one more transformation. Here, okay, we have to get action take. Can you see that? Take order, this one. What does it do? Return the first n element of the RDD using either the natural order or a custom comparator. All right, means the custom order. So means that you need to provide how many data? Here we need 3 data and ordering. This ordering is the trick here. Let me show you. I want to say that top words. All right, please get this word frequency, means, you know, this one, and do this one for me, please. Take order. All right, n means 3. So guys, here you need to provide how you want to add it, right? The key is the concept. A function used to generate key for comparing. So comparing means that I have to compare and then select the first 3. If you want to do like this, if you run just this one, all right, if I do like this and if I say, okay, oh, sorry. And if I say just print it out, all right. What's going on, guys? It's going to select the first 3 with the lowest numbers, I'll have to say with the highest numbers. If you want to provide highest number, you have to provide key and then lambda, and then you have to say get each x, okay, and then reverse it. Okay, reverse x1. What is x1, guys? Again, this is x, all right, and then take the minus of this because I want to reverse it, okay, into the descending order. Get Apache and get, you know, this one as index, as index 1, and then reverse it. And if I run, okay, you can see that, right? So by about 9%, with about, you know, 6% and 6%. So maybe you can make it much better. How? You can say that, you know, for word and frequency in top words. Okay, so word is 4 now and frequency is this number, right? I want to say that. Print, please. What to print? Let me use format. Guys, this is really great practice. Also, you can, you can practice Python. So just give me, you know, 2 decimal. Okay, do 2 decimal. The format. So for the first one, this one, please give me word, means this. For the second one, frequency. If you run it, perfect, guys. 9% for 6% programming and 6% language. I hope you enjoyed this session, guys. We went through Spark using Python. We call it PySpark, from 0 to see how to work around with PySpark. We went through, you know, with the basic syntaxes, and then we made, you know, this challenge. And I highly recommend you guys to watch this video as many as you can to grab the points.